Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about the Chandrayaan-3 mission that ISRO is going to launch in the next week. And by launching of this mission, ISRO is trying to or aiming to explore the polar areas of the moon, and that is why this mission is very critical, very important, because India will become the second country in the world to have a soft landing on the moon. Now if you try to understand the context of this particular mission, obviously on the 14th of July, that means almost 3 days from now, the lunar mission is going to be launched from obviously the Sriharikota island, which is nearby Andhra Pradesh, and this is going to be the third lunar mission of India. Before that also, India has launched Chandrayaan 1 in 2008 and Chandrayaan 2 in year 2019, which unfortunately failed to yield the desired result. So if we talk about since 2019, the Chandrayaan 2 mission, it partially failed because the lander and rover of the Chandrayaan 2 were not able to land on the moon surface, on the lunar surface, in what we can call as the soft landing. Thus, Chandrayaan 3 will reach the lunar orbit almost a month after its launch. That means the mission will be launched on 14th of July, and the Chandrayaan, along with its lander that is called as Vikram and the rover that is called as Pragyan, will land on the moon somewhere on the 23rd of August. So how this Chandrayaan 3 will be sent into the space, and thus it will be launched by one of the heaviest rocket that India has in its arsenal. ISRO actually has its arsenal, that is called as LVM-3, which stands for Launch Vehicle Mark 3, and it has a gross lift-off weight of almost 640 tons with overall length of 43.5 meter and 5 meter diameter of payload fairing. Now, payload fairing refers to the nose ship equipment that we can see in this particular picture of this satellite, which is generally to protect the satellites or payload and the rocket as well from the aerodynamic forces that the rocket faces when it is flying at such a high speed and cruising at such a high speed in the atmosphere of the Earth. So overall launch vehicle, apart from that, we can also talk about LVM-3. It can carry a weight of almost 8,000 kgs to the LEOs. LEOs refer to lower Earth orbit, which is roughly about 200 kilometers from the surface of the Earth. However, when it comes to the geostationary transfer orbit, that is called as GTO, which lies very far away from the Earth's surface, almost 35,000 kilometers away from the Earth's surface, it can carry only half of its 8-ton payload capacity. That is almost 4 tons of payload it can carry to the GTO. So that is why we have two different criteria. 8 tons of payload in the LEOs and 4 tons of payload in the GTO can be carried by the LVM-3. However, if you talk about the world's most powerful rocket, that is Atlas V, LVM-3 is still much more weaker, or much more, what we can say, not that much stronger as the Atlas V. However, it will serve the purpose of transferring the Chandrayaan-3 into the moon's orbit or lunar orbit. Now, the most important and interesting question that comes into our mind is how this mission of ISRO is different from the mission of other countries which have tried to land their rover or land their craft on the moon. So first of all, the major difference comes in where ISRO is actually trying to land its lunar mission. For example, the landing site of the latest mission is not different. It is more or less same what was the landing site of the Chandrayaan 2, which is near the southern pole of the moon. Obviously, if you look at the moon here, we have this northern pole, we have the southern pole. This is the lunar equator. So about 70-degree latitude, that means from the equator, if you go somewhere, 70-degree latitude will be around this region, because we're talking about the southern pole. So around this is area where the ISRO will try to land its Chandrayaan 3. And if successful, it will become world's first mission actually to soft land near the lunar south pole, because all the previous spacecraft which different countries have sent, they have landed on the moon very closer to the equatorial region, a few degrees latitude either north or south of the lunar equator. And if you talk about the furthest that any spacecraft has gone from away from the lunar equator, it was Surveyor 7. That was the aircraft launched by NASA, National Aeronautics Space Administration Agency of USA, that made a moon landing way back on January 10, 1968. And even that time, this spacecraft, that is Surveyor 7, was able to only up to 40 degrees south of latitude. That means somewhere around this area, Challenger 2 was able to land. And then Chandrayaan 3 will land much more farther, very closer to the lunar equator. This lunar equator will be 90 degrees south, so around 70 degrees southwest, where we have the plan to land the Chandrayaan. So how the landing choices are made, why countries till now have preferred equatorial region of moon rather than polar region? So answer is very simple. First of all, it is much more easier and safer to land the lunar craft near the equator. And why it is so? It is because both the geographical terrain, the geographical features of the moon in these areas, as well as the temperature of the moon in this area are much more hospitable as well as conducive for a long and sustained operation of instrument that is present on this craft. Third point is the surface. If you look at the lunar surface near the equator, it is much more smoother. Smoother means there is not a lot of variation on the in the relief, in the height and depth of the lunar surface in these areas. There are absence of steep slopes and there are very few hills or craters. That is why the aircraft, once it has landed, or the lander craft once it has landed, will be able to smoothly move around the region without facing any kind of obstacle or obstruction. And last but not least, if we talk about the amount of sunlight that is falling on the moon, it is present in abundance amount in only the equatorial areas, at least on that side which is facing the earth, thus offering a regular supply of energy to solar power instrument. Because if you talk about the craft, the lander that will excavate, that will extract resource, samples and study the moon's geology, that craft will be powered by instrument which will run due to solar on the solar energy. There is no other way we can send fuel to this fuel on the moon. So that is why it is very important to have sufficient light for this craft. So why polar site is being preferred by ISRO in this instance? So first of all, obviously it is very challenging task because it is a very different and difficult terrain, because many of the parts in the polar areas lie in completely dark region, because the tilt of the moon's axis is such that sunlight is not able to reach any time in the polar areas of the moon. And since sunlight never reaches in this area, temperature also are very drastically very low, almost 230 degrees below Celsius, 230 degrees Celsius, minus 230 degrees Celsius. That is what temperature can reach sometimes. And thus lack of sunlight, extremely low temperature, it creates difficulty in the operation of instrument, because we just have discussed most of the instrument on the craft basically runs on the solar power. In addition, obviously near the polar areas there are large craters all over the place, ranging from few centimeters in size to those extending to several thousands of kilometers. And that is why the damage, obstruction and the obstacle that a lander has to face will be much more greater, and the damage and the probability of failure of mission will be relatively also higher. So why ISRO is interested, or other countries, for example, also are interested in polar region? First of all, first reason is obviously, as we have discussed, the polar areas of moon have very rugged terrain, and that is why it has largely remained an unexplored territory. And that is why we are attempting to find something unique, find something different that has not been discovered till now by any countries. Second, as we have discussed, there are deep craters that are present in the polar areas of the moons, and these deep craters are indications of the presence of ice molecules in the substantial amount in this region. So once we are able to explore through these deep craters, we'll also will have full confirmation that what is the probability of water, availability of water in the on the lunar surface. And third, if we talk about the first Chandrayaan mission that was sent in 2008, that time the orbiter of the Chandrayaan mission, which was orbiting around the moon, it has also indicated the presence of water on the lunar surface with the help of the two instruments it has on board. And last, as we have discussed, since sunlight is never able to reach in the polar areas of the moon, it has extremely cold temperature. And since it has extremely cold temperature, what we can understand is anything that might have trapped in these areas billions and billions of years ago would remain frozen in time. There will be no changes in these materials. There will be no changes in this, what I can say, gases or solid substances or any kind of substances. And thus, if we are able to analyze the rocks of these regions, soils of this region in the north and south pole of moon, it could provide a very important clues to the early solar system, that how solar system has began, what happened in the initial days of solar system, how moon has formed, how earth has formed, and how all other planets has formed. So let us try to understand the distribution of sunlight on the moon, that why it is so difficult to land on the lunar poles, and why it is always dark. So answer is very simple. If we compare the axial tilt of Earth Moon, we can clearly see the Earth is tilted at around 23 degrees from its perpendicular to the perpendicular to the Earth's orbit. At the same time, Moon is only tilted at 1.54 degrees, and it is the tilt of the Earth that allows sunlight to reach even in the North Pole and South Pole region. But since Moon is tilted very slightly, only 1.5 degrees, the sunlight is only incident in the equatorial areas around that, and never able to reach beyond 60 degrees either in the north or south of the equator. And thus what we can say that it is due to this unique geometry of moon, sunlight never shines on the floor of a number of craters near the lunar north and south pole. These areas have been characterized as permanently shadowed region or PSRs. And as far as NASA is concerned, it has released a statement where it says that water which happens to find its way into the PSR may remain there for a very long period of time, because obviously water can only get lost if it is in liquid form. There is a high temperature and then it evaporates. But if it is in the lying in the areas where temperature is so far below 0 degrees Celsius, minus 200, 230 degrees Celsius, obviously water will remain frozen in its natural solid form for an extended period of time. So last what we can discuss about is how moon has formed, because this is very interesting question. And though we not have 100% sure answer, two best theories which we have today is first what we call as Theia theory. Theia theory, or also called as Great Collision Impact theory. As per this theory, in the initial days of the formation of the solar system, when Earth was in its initial stages about 4.2 billion years ago from now, Earth was what we can call at that time is referred as proto-Earth. And in this time, a Mars-sized object, not Mars, but similar to the size of today's Mars, collided with the Earth. And as a result of this collision, this Mars-sized object is what we refer as actually Theia. So basically what happened, you have a collision of Mars-sized object, Mars-sized celestial bodies such as Theia with a proto-Earth. And due to this collision, what happened? The amount of heat generated was so huge that a large part of Theia and proto-Earth fused together to form a larger celestial body, a larger celestial planet. And a small part of the debris that was generated due to this collision started to revolve around this larger body, and gradually all this debris material rocks that were generated start to join together, start to accumulate together to form a small object which we know today by the name of moon. There is one other theory that is called as multi-impact hypothesis. Multi-impact hypothesis is similar. It says that it is not only a single impact that has created the moon, rather than numerous impact has happened on the proto-Earth, which has created disk of debris around the Earth. Then as the disk of debris accumulated together, what form is a smaller size of an object that we call as moonlet. Moonlet is much more smaller as compared to the size of moon today. And then gradually again next collision happened, again debris generated, again this debris is attracted by the gravitational field of the moon, and thus what is happening, gradually the accumulation of debris in the moon, around the moon, has led to increase in the size of this moonlet to the current size of moon. So Theia hypothesis and the multi-impact hypothesis, these are two best hypotheses to explain the formation and development of moon in the early stages of the solar system. However, if we come back to our main point of the Chandrayaan 3, how this Chandrayaan 3 is going to play, what kind of role it is going to play for India. So obviously, this mission is coming in background of recent decision of India to join the Artemis Accords. About Artemis Accords, we also have made video. If you want to know about what is Artemis Accord, you can watch our channel. So India has decided to join the Artemis Accord, and in this group, the countries which are in the Artemis Accord, if the Chandrayaan 3 mission succeed, India will become the second country to have soft landed a rover on the moon. Thus, Chandrayaan 3 offers opportunities for India to lead the world's response to the moon's growing importance, both in the scientific field as well as the political field or political milieu. So that is all about this particular video. I hope you understood about the Chandrayaan 3 missions and related information. If you like the video, please hit the like button, share it with fellow aspirants, as well as subscribe to our channel for more such content. Thank you very much.